Yep. Let's open this up. First off, I just want to point out that many of our lectures are available to view. If you go to YouTube and you look for this phrase, Astronomical Society of Long Island presents, I put them in front. And if you've ever missed one, they are out here. I've gotten permission from everybody that wants it up there. So I just wanted to point that out to everybody. This way we get the view count up. So let's go into the presentation. Look at back over here. Okay, and so tonight I'm going to be talking about a few objects in the night sky, and then on to the main part of my talk, which is going to be how to find things in the night sky when you don't know where anything is. And given the fact that this is the third time I'm doing this, and pretty much in the last 3 months, you're all gluttons for punishment. So that's all I have to say. So some lunar events, not really any. So I found this nice chart of the lunar phases this month. I'm not going to harp on that. The other key points, sorry about that. Apogee is on March 3rd, and the aphelion is on March 5th. Conjunctions. This is the big conjunction. This is, again, if you looked at this down here, if you looked at the time, we've kind of passed that time. So the main conjunction was then, and it would be visible for a couple of hours. So I think it's probably just about setting right now. But not all is not lost. Tomorrow it will be a washout too because there'll be cloud.
See in advance of one day.
This is just a screenshot.
Oh.
Yeah, we can go back if at any point you want to see. No, I can bring up Stellarium and we can look at it. So again, as I see, I set this from Massapequa because that's where Stellarium finds it the closest. But it should be very easy to find. I was going to give a challenge to those daytime astrophotographers to find the conjunction in the noonday sun, because it is the third and fourth largest objects in the sky. But I think they can't. You can't even find it in the clouds. Let's see. It's going to sink in here. Let me make it.
I got it today.
So they'll fade into darkness, and both objects are going to be in the constant, which is kind of a little silly because you're not going to be able to see it. So let's go on. So then we have on the 19th, we have the moon and Saturn. Now these are going to be near evening observations. The pair will be visible. I'm sorry, this is going to be in the morning, just before morning. I'm sorry, at 6 a.m. And it'll rise all day, and it's going to set sometime in the afternoon. So again, if you wanted to take a look at this, you'd have to get to a very easterly direction. Now, one of the things I'm going to add, because of Ed's suggestion, was I'm going to see if I can bring in use of some filters to view some of these objects when we're looking at them visually, because looking at them through different filters will give you different enhancements, like looking at Saturn's belt, maybe look bluish gray, brown, or red. Such features stand out well to a red, orange, or yellow filter. Occasionally, bright patches look best in a green or a number 58 filter, and the highlights of the rings of Saturn, you would use either a light green, a number 56, or a light blue, a number 82. Now, these are just standard filters. You don't need to spend a lot of money. I think Celestron sells a starter set of filters for a reasonable price. I'm not sure what the price is, but you need to go look for it.
Buy a 4-pack of colored filters for about $30.
Okay, if you didn't hear that, you can buy a 4-pack of colored filters for around $30. So again, this is going to be on March 19th. The actual conjunction is going to be, the closest is going to be is 11 in the morning. So if you get up just before dawn, you're going to see it. So you can have so that's basically what it's going to look like. Then the next conjunction is going to be the moon and Jupiter. Again, that's going to be on March 22nd. The moon at that point will be 1 day old. The pair will be visible as soon as it rises at 7:30 until it sets at 2000 hours. The moon will be magnitude minus 8.3. That's, even though it's 1 day old, it's already the brightest, still brighter than anything else. And Jupiter is going to be a -2 magnitude. So the best time, I think, to observe it is going to be just at sunset. It's going to be low in the horizon. And as you can see here, Venus is going to be nearby as well. Now, to view Jupiter, I would use a number 38A dark blue filter, and this will enhance the planet's zones. Blue filters also sharpen bright cloud features. They're a popular choice for the study of Jupiter's disks because it strongly rejects red and orange wavelengths in the belts, thus enhancing the boundaries between the reddish belts and the adjacent bright zones. It's also useful for viewing the Great Red Spot. A number 23A red filter brings out details in Jupiter's equatorial region, and it sharpens the contrast in the major belts. A 23 filter is good for studying the clouds. My keypad is very finicky. So on the 24th, you're going to have the moon and Venus. Now that, again, it's going to be visible when it rises about 8 in the morning, and it sets around 2200 hours. Takes extreme caution. As I say, don't try to do this without a strong filter, or try to get the sun not in your way because you will not hurt. But this could be a nice target for our daytime astrophotographers, because the moon will be a magnitude -10 and Venus is going to be a -4, and they're both in the constellation of Aries. Now, the features of Venus atmosphere range from dusty shadings to bright spots. You may be able to spot some of the most famous images, like a C or Y-shaped feature centered on the planet's equator through a number 47 violet filter. It is most useful in observing Venus because of the ability to reveal dark shadings in the upper atmosphere. If anybody else at some point has a comment, please go ahead and say something.
3.5.
You look like you want to say something, Steve.
3.5 days, this should be a really nice looking crest also.
Okay. If you didn't hear that, Dave says in 3.5 days, it should be a nice looking crescent. Yes, that.
Just in relation to filters on planets, for those who have never worked with color filters on planets, the effect is very subtle. This is not going to be a case of I put this filter in and boom, I've got all this explosion of detail on planet. This is going to be a case of bringing out very, very subtle shadings, very, very subtle details. I spent whole nights just rotating filters around looking through, and they do make a difference.
Right.
You know, just to set people's expectation. So it's going to be
Right.
There's a place in that cloud band that I couldn't see before. Now I can see it. Right, but it's not going to make. It's not like all of a sudden it looks like an astrophotograph.
And it also probably depends on the size of the scope you're looking through.
No, that's
Well-
like they're inexpensive filters, they're dark filters.
Right.
And they need special filters that are not electric, but cheaper and expensive. You're gonna see a very subtle difference.
Right. Well, the more ambitious people will get the dielectric filters. Well,
Oh, you tell us about the duration.
When I have the cheap one, I will actually get. I don't know if there were filters that are extremely hot. Really?
so, so if I may, so the moon and Mars is going to be the only one that actually is going to be easy to see. The others are, like I said, are going to be either just before sunrise or very close to sunset. So this is going to be on March 28th. It's going to be around, it's going to rise around 9 o'clock. The moon will be 7 days old. The pair will be visible soon after it rises at, so it rises at 10 and it'll set at 2 in the morning. So the moon at this will be a magnitude of minus 11.7 and Mars will be a magnitude of 0.9.
So really pretty open cluster right next to Mars that night also, and
You wanna come up and-
So right.
Did you hear what, can you hear what Dave was saying? Okay. So the going on to the filters, again, subtle changes or the non-existent dielectric filters. So there's, I didn't know this term, orographic clouds on Mars, and they're made from water created by wind passing over Martian mountains and volcanoes. To view the orographic clouds, use an 80A blue or a 47 violet filter. For lower altitudes, a 58 green works better. It's useful for detecting high clouds and haze in the Martian polar caps and during the violet clearing. And here's a chart of all the different filters and the planets. And if anybody needs that, I can forward them a copy. So I thought this was the most concise one. I'm not sure how accurate it is, but I think if you're interested in enhancing your viewing of the planets, it couldn't hurt. So, and later on, if there's any particular filter that you want to have more details, I do have some definite, I have some more information about them, but I'm not going to read them all now. So if at the end you had a specific planet and filter, I can review exactly what each filter will enhance. So for those that like comets, we have a comet that's reaching perihelion, but it's going to be like magnitude 11. So unless you have a really big scope or really dedicated, you're probably not going to see it. And that's going to reach perihelion on March 29th.
Is it gonna be green?
We'll come with the afterburners on it, so you can see. All right, so, and here's all the other times that you can be able to see this. Again, if anybody is interested. But I figure we're all kind of happy now, so I had to find one at least. So the main talk I'm going to talk about are asterisms. Basically, what I'm going to do is for people who have no idea where anything is in the sky, I'm going to show you very simple ways. Yes. Oh. And unfortunately, because of the weather, I was planning to go outside and actually use a laser pointer and show you how easy it is to find things in the sky. But we're going to pretend that we're doing it. So if I could start, as you know, with the ever increasing light pollution, the skies, our night skies are becoming less and less starry-eyed. I don't know what the proper term is, but it's becoming increasingly difficult to identify even the major constellations. I mean, right now we have 3 major constellations that you could see, that maybe 2 of them you could identify, Orion and the Big Dipper. And I challenge you to find all the stars in the Little Dipper. But let me take you, I digressed a little bit. So if I can borrow from the movie Guys and Dolls, where Nathan Detroit's rolling the dice and he keeps rolling 7s and he says, but there are no spots on the dice. He says, well, I remember where they formerly were. And it's kind of like us going outside and looking at the sky. Well, yeah, I kind of know it because in the past you could see more of it. And so if you're of a certain age, you still can pretend to know. So I have a question though. When you're going outside, are you seeing Orion, Ursa Major, and Ursa Minor? I say you're not. What you're seeing are some asterisms within Ursa Major, Ursa Minor, and Orion, but you're not really seeing the whole constellation. Can you make out the shield in Orion? Yeah, maybe. Can you make out all the details? Probably not. So the part we're going to start with, and the one in this night sky is the most obvious to find, is Orion's belt. I think if you know nothing else about the sky, you can find Orion's belt. So from there, we're going to find some of the major asterisms. So let's start. So the biggest asterism is the winter hexagon. Now, those that know it can spot it right off. Once you know it, you can't. It's one of those things you don't forget. But it's also known as the winter circle. It's a prominent asterism formed by 6 stars that dominate our sky in the winter. It encompasses Rigel from the Orion constellation, Aldebaran in Taurus, Capella, Pollux, Procyon, and Sirius. So within the winter hexagon is a smaller asterism called the winter triangle, or the Great Southern Triangle, and formed by 3 stars of first magnitude: Betelgeuse, that has made the news in recent years because we thought it was going to blow up, Procyon, and Sirius. These 3 bright stars form an equilateral triangle, and each are clearly visible, but just like those stars in the winter hexagon, may not be so easy to identify. So to find out the first star in the winter hexagon, Sirius, we start with the most identifiable object, like I said, the belt of Orion. Sirius is easily found by drawing an imaginary line. And you guys, oops, sorry. Let's stop doing that. Can't move my hand over it. It's a very sensitive keyboard. So let's see. We have a laser pointer. So you can all see the laser pointer. So if you start, and I've put in the belt here, I made them red to make it easier to find. So if you start at the belt and you draw an imaginary line down, first bright star you're going to come to is Sirius. It's also the most southern star in the hexagon. So if you get lost in the winter and you want to know which direction south, just find Sirius, and you'll still be lost, but you should know which direction south. Okay, getting back to where it was. Okay, so the second, Sirius is also known as the dog star. It's the brightest star in the night sky, visible anywhere on Earth except for areas far north. It's a white star pointing due south. It's also but it's also a double star. I'm not sure what magnifications. I know we have some people that like splitting doubles. I don't know if Ed, do you know or anybody know what the magnification you would need in your telescope to split Sirius?
The challenge with splitting Sirius is that the Sirius being so bright, the second star, which we call is a very low magnitude star. I don't remember the number, it might be 7 or 8 or 9. So they're very close. So you got to get the magnification way up there. It becomes hard to see the pup unless you have extremely good seeing. And sometimes what the best thing you can do is you get Sirius, get the magnification way up, and then move Sirius out of the field of view. Then you have a better chance to spot the pup.
Okay.
One of the tips I give people on splitting doubles is I like to use a zoom light. That's why using a zoom light, when you're using single focal length eyepieces, you say, okay, I got Sirius. Let's see, let me go to the next magnification. Well, was that star there before? I don't remember. And is that the one I'm looking for? Well, I'm not sure. If you zoom at these and you zoom in, so it's split. And you actually watch the split happen.
Thank you.
I only do my splitting doubles in real life. Is Sirius B?
Series B.
Okay. I believe that's in a elliptical orbit around Sirius.
Right, so at some points it will be,
Periods in terms of decades when it's too close and then it's
right,
further. But
Correct.
that's one of those challenge double splits, where it's like, okay, you really want to do some split? Okay, let's see if you can find it. And it's the seeing that's probably as much of a problem as it is the fact that Sirius is so bright.
well, thank you. It, hopefully you've heard it at home. I can't repeat all that.
Yeah.
The next star we're going to find, so we found Sirius, again, drawing a line from the belt in that direction. We have Capella. It's a bright star in Auriga. It's the sixth brightest star in the night sky. And it's the third brightest star in the northern hemisphere. It has a magnitude of 0.08. And this is not a single star, but it is a quadruplet. So you have two pairs of two stars, and the primary is composed of two bright yellow giant stars. To find the rough position of Capella, draw a line from Sirius, which we've already found, through Betelgeuse, which I think everybody kind of knows where that is. If you didn't, you just find the belt and it's the brightest star. So usually the hourglass shape of Orion is still the easiest thing to identify.
And it's red.
And it's red. So it's angry. So if you draw a line up from Sirius to Betelgeuse, about 2.5 times that length, the first bright star that will be near it is going to be Capella. Okay, so now we found two of the stars in the winter hexagon. Next we'll come to Rigel. It's the seventh brightest star in the night. It's another star that's in Orion. It's a massive blue-white supergiant variable star. It appears as a single star, but actually it's another one that has 4 stars. Trying to find, I guess, being a lone star is like ours is the exception, not the rule. To find Rigel, draw a line from Betelgeuse through the middle star of Orion's belt. So if you come over here, again, probably you'll know where Rigel is, but if you didn't, you find Orion's belt, you find Betelgeuse, you draw a line equidistant away from the belt, and there is Rigel. Procyon is the 8th brightest star in the sky and has a apparent magnitude of 0.34, and it's the brightest star in Canis Minor. The name Procyon comes from the Greek, meaning before the dog, referring to the fact that it rises just before Sirius, the dog star. To find it, you're on your own. No, I'm just kidding. To find it, you imagine that Sirius and Betelgeuse are at the base of an equilateral triangle, then draw a line midpoint between the two, and where the two lines of the sides would meet, you're going to find Procyon. So if you start here and just kind of draw a line out, the length of the line, it pretty much stands out. There's not many bright stars around it. So Procyon should be another star. Again, these are the 6 brightest stars in the night sky. So they should be easy enough to find. Aldebaran is another bright star, obviously. It's in Taurus. It's the 13th brightest star in the sky. Apparent magnitude is a variable star between 0.75 and 0.95. It got its name, translates as the follower, because it appears to follow the Pleiades cluster across the sky. Fairly easy to find in the sky as it lies close to the Orion constellation. You will come to a bright star. So you start with the belt, And instead of going down to Sirius, you kind of follow it up till you find the first bright star, and that's going to be Aldebaran. Don't worry, we're getting to the end of this. So next, let's try Pollux. Now, personally, I don't know why, but I don't care where I am. I can look up, and if Gemini is up in the air, even if Orion is not, there's something about Castor and Pollux, the spacing of the two stars and their brightness. When I look at them, I said, oh, there's Gemini. And all this time I don't know what triggers it, but if you don't have that, you can always go and find it the way I'm going to tell you how to find it. It's the 17th brightest star. It's evolved orange. I guess it's an older star. It's a parent magnitude of 1.14. You start by drawing a line from Orion's bright star Rigel through Betelgeuse and extend it about 3 times. So if you start here and you go 1, 2, 3. Now, most likely you probably wind up on Castor. So, but if you look to the left and there's a star, then you're on Castor. If you look to the left and there's no star, then you're on Pollux. So either way, you're in the vicinity and you'll see both of those stars. It's and that's my honorable mention, which I think it should be but I like hexagons. It's a better shape. So that's how you find. Now, Castor is interesting because that's also as a sextuplet star system. So if you're into splitting, good luck. Any questions about what I've done? Does it make it simplify so you think you can find any of those stars? And again, if you need the deck, I can always put the deck out there. Well, you'll have the video, whatever that means. So now we're going to use these asterisms to find some other things. So the first is the Orion Nebula. Again, don't really need to have it, but for those, just a way of finding it, we're going to use the stars in the winter hexagon. Actually, what we're going to do is we're going to go back to Orion's belt. And if you below Orion's belt, there's another asterism called Orion's sword. And that's denoted by 3 bright stars that seem to be hanging off of Orion's belt. So if you look closely, one of them is really just a fuzzy patch, even to the naked eye. And you would be correct in assuming that that's not a star. It is a diffuse reflection nebula housing within it a stellar nursery. It's approximately 1,300 light years away from Earth. It's the brightest, if not the brightest, one of the brightest objects in the sky for nebulas, and has a visual magnitude of 4. And like I said, you can see it without binoculars, but when you hold binoculars up to it, you really start seeing some nebulosity. And not to be undone, inside the Orion Nebula has its own asterism. It's the trapezium cluster. That's because within it, there are 4 prominent stars that look like a trapezoid, and they're visible even in modest-sized telescopes. 2 of these stars, actually, again, can be split into other stars, so they're stars within stars. Now, the best filter to view this in is a UHC, or ultra-high contrast type filter. It brings out more detail. However, it will darken the image. So you may want to use scopes that are at least 8 inches or more, because smaller scopes, the image gets very dark. You'll see the nebulosity, but the stars may be a little harder to see. And just if you didn't know where it was, it's there. So you can actually, even in this image, going. Okay. Let me turn that off. So even stellarium, in that image, it looks like a nebula. I thought that was cute. And there's a picture, not what you'll see when you look through a telescope.
if you go back to your earlier slide, you have that sketch
Right. What you will see,
on the left.
this one.
That's much closer to what it would look
Oh.
like in the night.
This one. Yeah, that one, or again, that might, in smaller telescopes, you might see something like that. Now, I bring the Horsehead Nebula. It's not really, unless you have really good viewing and a fairly large telescope, you're probably not going to see this in here, but I just thought that it's something, again, using what we've learned of the asterisms and how to use them to locate things, it would be interesting. So this is called the Horsehead Nebula, or also known as Barnard 33. It's a dark nebula located south of the star Alnitak. It's the left star of Orion's belt. It's located about, again, 1,300 light years away. A 12-inch reflector is probably a minimum that you get to see the skies, but unless you have an image intensifier, which will make it pop out.
So honestly, people 20 years ago, 30 years ago, were at a cluster using 18-inch scopes, and they had a black cloth over their head to eliminate any noise nearby, and this was 30 years ago. And then some kind of beta filter, there's a beta, and it would be, I think I saw it, so.
Yeah,
Of course, we had John's 32, I guess that was a piece of paper. But when he means large, he means
large. And again, just to show you, here it is, again, right off the left star of Orion's belt. So you can just kind of like spots on the dice, you kind of know it's there, even if you can't see it. Hades cluster, also known as Caldwell 41, 41, is an open cluster. It contains hundreds of stars. It's thought to be about 625 million years old, and the nearest open cluster to the sun, therefore it's one of the ones most studied. Now again, this is what it would look like in a moderate telescope. This would be, again, this is Stellarium's picture of it. I also took one of my own, and again, the way to find this, it's another naked eye object. To find it, use Orion's belt and a noticeable line of 3 blue stars in conjunction with Orion the Hunter. Draw a line westward, generally towards the direction through the belt. You'll come to the bright star Aldebaran. I'm getting my Star Wars mixed up in this. So here's the belt, and again, if you follow it like we did, it's one of the 6 stars that's in the winter hexagon. So just off of the star, you're going to find Hades cluster. So that's fairly easy to find, right? You've looked at it.
That's binocular target,
Okay.
low power, telescope.
Okay. So on clear nights, something to try for. Again, if you have a go-to scope, it takes all the fun out of it. So if you wanted to learn things and how things were done before go-tos, it's basically what this is the star hopping in the rudimentary form. And I think this is the last one I have, is the Pleiades. Now, the Pleiades isn't exactly, it's outside of the winter hexagon, but again, it's probably one of the most prettiest collection of stars you can look at. Definitely telescope, binocular object, and small telescopes. They really, on clear skies, it's just an amazing thing to look at. Here's somebody's, I guess, through a binocular. This is what it would kind of look like. Here's somebody's another sketch. They did an invert negative of the item. So this way they had a white piece of paper and they just filled in the black squares, black dots to show the approximate locations of it. And then here's your some of a image I found on the internet. It's the old story. It's the seven Pleiades, the seven sisters in Greek mythology, and it's believed to have been discovered or been known since the Bronze Age. So this is a very old collection of stars. And again, to find it, if you follow the Orion belt, you just kind of go out past where Hades is, and I guess another point. But again, when you look up, it'll be a fuzzy patch to the naked eye. It'll be standing out in itself, outstanding in a field. Never mind, that's an old joke. And that is my talk.
It was open, we talked about it before, but again, we may have new people or.
Okay, let me.
Ladies,
Yeah.
Japan is called Subaru.
Yeah.
Look at the emblem on the front of the car. It's the seven sisters. It's seven. When you go look at the Pleiades, there's really only 6 bright stars. So there's a whole concept of why it became known as 7. What's the science of how the universe works stuff? But going back in history through Native American lore and Chinese lore, it's always identified as the 7 something. But there's really only 6 bright stars. So the question is, what happened to the 7th star? And some of the lore actually explains what happened to the 7th star. There were 6 children, and the one ran away from the bear. And the thing that people seem to find interesting is that that's the emblem of the front of the car.
So, okay, thank you. That's very nice. It's, anybody still awake out there? Steve, do
Yeah,
you
I have a question.
Yes,
I have a question. Am I up? Can I ask a question?
you're on.
So where did you get those nice sketches from? You might have said it, but I missed it.
Googled YouTube and just found ones that I think would have been appropriate. I did not,
Oh,
could
okay.
have, I guess, them.
Well, because we have an ex-Long Islander living in Texas that's still an AOS member, John Ecarino, who does the best sketching I've seen, I think. I mean, he's like a pro. So I thought maybe some of them might have been his, and maybe they are.
They could have very well been. I do apologize. I did not give credit to whoever the artists were. Yes.
Well, I always say if I weren't so lazy, I would do sketching, but instead I do astrophotography because I'm too lazy to sketch.
So,
Yes.
Steve, this is George.
Hi,
Yes,
George.
You challenged us. Do you see the constellations? And I don't see the constellation. What I want to say is that with my camera, actually, I see a lot more stuff that you can see with your naked eyes. So with a decent lens, not very wide, 24 millimeters or whatever, you get a good chunk of the sky, and you see. You can look at Orion, and you can see the head, you can see the bow, or you very easily I can tell Taurus, the head around the Aldebaran and the Hyades. So if you have a camera, try. I'm trying to encourage people to. You don't need to make like nice pictures. Just see what comes out. It's really cool.
Oh, you're all right. You're right. Even a simple camera and taking a 10-second exposure is going to reveal a lot more of the night sky than our feeble eyes can see. But I'm just was trying to give a beginner's talk on at least trying to appreciate things that are in the night sky. And I was at Custer last week, and everybody's pointing up, oh yeah, there's that. And I was saying, all this time, yeah, I found Orion's belt. I'm good. Thank you. Does anybody else have an object that I did not cover that's easy to find that would like to share? Okay, I'll take that as a no. Do you, something?
Yeah,
Okay.
Steve,
Yeah, Bob,
this is Bob talking.
yes,
I don't know any by name offhand, but that particular area of the sky has loads of really beautiful double stars, which are, I mean, they're not visible as doubles to the naked eye. But in a telescope, you can spend hours just going from one double star to the next in Orion, Canis Major, and I guess Gemini, Orija as well.
well, I don't, do you have stellarium? Do you want to, maybe, if you could point out some, we could,
Off the top of my head, I can't think of any
okay.
of them, but does stellarium actually show a double star if it's
If you zoom in, yeah,
you zoom in? That's
if you zoom in,
cool.
it's its own little planetarium show, if you can,
And it says
I
it
mean,
too.
is there, I can bring it up if you want.
It also
Is it-
says it's a double star. It's on the left, and when you click on it.
Mhm. Yeah, I'm gonna get a map here. It'll take a couple of minutes here. And let's see, I have a list of double stars here. I see Sigma Orion might be a good one to look at.
So what do you,
Also the sword of Orion combined with the belt of Orion and Sigma Orion is called the mirror of Venus. It looks like an handheld diamond clustered mirror.
oh, okay, I'm pinching and zooming and I,
See here, the belt is Sigma and then the sword creates a handheld diamond.
Venus, and I never knew what it was.
That's it. It's called the mirror of Venus, the sheath with the sword of Orion.
Oh, look at that. Yeah. You can see a little piece of the secondary star coming from, at about 11 o'clock. And now it's closer, closer. Look at that. It's almost split. There, yeah, that's cool.
See, if you hit K, it should stop.
no, I'm doing it.
There it is.
Okay,
So you see, we just split Sigma Orion.
Nice.
any other ones you,
Let me see. I got a book here. Let me. That one looks like it might be a little too challenging.
Separation for Sigma Orion.
How about
there's,
is it yeah, Iota Orion.
It's just that green. Search it.
Okay, there it is. Very close to M42.
Must be a front or behind.
Well, some of them, the second star is so tight, yeah, that they don't go in that far.
Yeah, it's supposed to be 2.8, 6.9. So maybe maybe the secondary is too small.
I mean, I don't know if Stellarium has every pair in there. It might not be one of the ones that they're covering.
But it's amazing what's hilarious.
Yeah. Oh, definitely. Well, the price is right.
Oh, yeah.
Anything else? Or should we, I guess you can stop recording.
Yeah, Alpha Geminorium. I see the Castor Pollux. I'm not too sure which one it is.
Oh, yeah.
Yeah, Castor. That's
Castor.
Castor. That's supposed to be 1.9 magnitude primary, 2.9 magnitude secondary, but they're kind of close. About 4 seconds.
I think you already split two before you got to that point.
Yeah. Yeah, there's 1, 2, looks like
One.
Hard to tell.
2,
Yeah, there we go. One's coming out.
3.
How many stars in Castor? 4. Oh, Castor 6.
6.
Yeah.
Not all can be resolved.
Yeah, some of them might be very small.
But I think that these are gravitationally bound in Castor. So they are all, it's not, they're just observing. There's a star here and a star here. The stars are actually a sextuplet. All right, Ken, I guess you can stop recording.
Okay.
Yeah.
I just wanted to come in, that this was